We're going to use trig now to solve, or our knowledge of trig to solve a trig equation. So let's have a look what we're being asked here. If tan of x equals 2 and x is an element of 0 to pi on 2, which is talking about our domain for x, find the following. Now the first thing I think of when I see a question like this and I have a domain, I draw the unit circle for myself and just shade in where this is. So 0 to pi on 2 is this region, all in here, and quadrant 1. So I also think about what the various things here are going to be in terms of positive or negative sign. Now I know that in this direction, this is our cos, it's going to be positive, so this will be positive. We're also in the positive region here for sine. Now for sec, remember that sec, look at that third letter, it's C for cos. Sec is 1 over cos x. Now because cos x is positive, sec will also be positive. And again with cosec, the third letter is S, S for sine. 1 on sine x. Sine x is positive, so 1 over sine x will be positive too. So all of my answers here are going to be positive. Now the first thing that I do know is tan x, and I'm trying to find this sec squared x. Now there's a couple of ways you can do this, but the way I'm going to do this is to identify that I've got tan, I'm trying to find sec, and from our 3 trig identities, we know that one of those identities that links sec and tan really nicely is this one. Sec squared theta equals tan squared theta plus 1, or whichever way it may be written a different way in your notes too. So what we're going to do here, we've got x, okay, so just replace that with x, doesn't matter what that is. And we are given tan x, so we know already, well, let's just label this for A, what tan is, so we can use this rule. So I'm just going to substitute in what I know, which is tan, which is 2. So tan x is 2 squared plus 1, which means that sec squared x is 5, and that means that sec x, take the square root. Normally this would be plus or minus the square root of 5, but because we know that sec has to be positive, we don't need that the negative branch. So our answer is going to be that sec x equals root 5. Nice. Now the next one, B, we have cos x that we're interested in. Now we just found sec x. Sec, remember, is 1 over cos. So if we know what 1 over cos is, if we flip this over, we're going to get cos x on 1. And let's flip this over. Any whole number is implied to be over 1 because that's how many wholes you have. So let's flip this over as well. So we're now going to have 1 over root 5. Anything over 1 is just itself. So we've got cos x equals 1 over root 5, and it's positive, which is what we wanted. Okay, so we've found 2 things so far. I'll just put a box around them so I can see them. The next thing is sine x. Now, because I have cos and I have sec, this sec isn't going to be very useful to me, but cos x reminds me of another one of those 3 useful trig identities, which in terms of x would be this one. So it's that sort of Pythagorean type. So let's use that now. We know cos x, which is 1 over root 5. We're going to square that, plus sine squared x equals 1. This is nice because squaring this, the square root disappears. And we're left with that. I should have some arrows there as well, just to say these are our steps as we go. I'm just going to rearrange this now. So sine squared x equals 1, take away 1/5, which is 4/5. And to finish off, taking the square root. Now remember again, you'd have the plus minus square root going on here. Because we know that sine is positive, we don't need the negative. And also, when you're doing square roots, if you're square rooting a fraction, you take the square root of the top and the square root of the bottom. You can do those separately. So what this actually turns into is positive square root of 4 over the square root of 5. So therefore, sine of x equals the square root of 4, which is 2, over the square root of 5. Just put a box around that. Beautiful. And that was our answer for C. Remember with the videos too, if I'm going too fast or too slowly, you can always fast forward or pause, catch up. So the last thing we're looking at here is D, which is cosec of x. Now remember that cosec of x is actually equal to 1 over sine x. And because we know what sine x is, this is nice and easy. It's going to be flipped over. So this is now root 5 over 2 is cosec of x. So to finish off, and actually I'll just put that all together so you can see the four answers that you've got. So it's all about using those trig identities that we talked about, the three special trig identities that link sec, cosec, cot, tan, and sine and cos, and using those to try and identify various trig identities, and then it's sort of like a domino effect, I guess, going through the question. So you can see here that you're using each one of these to help you find the next one. Also, just quickly as a final part of this, you may want to express your answers without the surds on the bottom, okay, which is really the proper way to do that. So this one is okay, this one's okay. To express these so that you have the surds on the top, what you do is you multiply the top and the bottom by the same thing. So here you can see that the denominator is root 5. Multiply the top and the bottom by root 5. And what that's going to do, I'll do this in red so you can see, is it's going to give you root 5 on the top. And then here, root 5 times root 5 is just going to be 5. So you've actually got rid of the square root underneath. Here the same thing will happen. You'll have 2 root 5 on the top, and root 5 times root 5 is 5 underneath.